so see what you guys remember from Algebra 1. So horizontal, right here, right? Flat like the horizon. All right. Does anybody remember what the slope of a horizontal line is? Do you remember? Yes. Okay, so any horizontal line has a slope of 0. A very long time ago, I used to write this on the graph for people, but this has a 0 slope. You can kind of turn that into a z if you want to. But if you think about it, if I just grab 2 points right next to each other, and I'm just sketching this on here. If I do my rise over run, I'm going up 0, but then I'm going over 1. Totally legal to divide 0 by a number. It's always 0, but that's why the slope of any horizontal line is 0. Okay, does anybody know just a general equation for a horizontal line?
No, y.
Yes, just like y equals 3, y equals 4. And this always throws people off. It's y equals some number. There's no x involved. And it always throws people off because you think x-axis is horizontal, right? And so you think it should be x, or a lot of people do. It's the actual equation of the x-axis, though, I can write on this graph here, is y equals 0, because all the y coordinates are the same along a horizontal line. So I call it, to help me remember, I call it horizontal. You can use that if you want to. I typed it into this lovely little example down here, but every single point as you go across here, I don't know, I didn't put a grid on this, but if you're up here, as you go across, the x's change as you go across, but the y coordinates would all be exactly the same. So it's just a requirement that a y coordinate has to be equal to some number for a horizontal line. All right, so vertical line, here's just like a little tiny example. Does anybody remember the slope of the vertical line? Undefined, yes. Okay. Now, sometimes, I don't know if you guys would have heard it called this, sometimes they call it no slope. Both of those are considered correct for a vertical line, undefined or no slope. And so a million years ago, I used to turn this into an N for no, there's no slope here. The reason for this, like if you grab 2 points, do your rise over run. Let's say they were right next to each other. I don't have a grid on here, I know that. But if I go rise over run, we're going up 1, but then I'm going over 0, and that is illegal. You cannot divide something into 0 pieces. If you have something, it exists, you can't divide it by 0. That is not defined, so it's either undefined or you can also call it no slope. All right, now, spoiler alert. This is just going to be x equals some number for any vertical line. I just call it vertexal to help me remember, because again, people get confused. Any vertical line, you guys probably think y-axis. The actual equation of the y-axis, though, is x equals 0, because all the x coordinates are 0 up and down. The y coordinates change as you go. This line right here, again, I don't have a grid on here, but all the x coordinates would be the same. The y's would change as we would move up and down that line. Okay, so all we're going to do, and I have some inequalities mixed in here too, so we're going to talk about that today as well. But if you just have to graph a horizontal line, I usually just tell people, like, find me somewhere where the y coordinate is whatever the number is. So my first little example, I just have y equals 3. So if I asked you to find me a point where the y coordinate's 3, most people will go there. And then if I say find me another coordinate, sometimes people will go on the x-axis or something. So anyway, but just think about this. So that's 0, 3. Like this would be 1, 3, 2, 3, 3, 3. So it's going to create a horizontal line across there. And that always trips people up because it's parallel to the x-axis. Okay, now, my second question, bless you, this one's an inequality. So I'm going to ask you 2 questions before I graph this. Where I put this, should it be like a dashed line or should it be a solid line? This is solid. If you see it, it's solid. So just find -2. We're going to draw a nice horizontal solid line there. All right, so as you read that, hopefully you say y is less than or equal to -2. So then I got to figure out where I want to shade. Do we want to shade above or below? Below. Okay, so this is saying my y coordinate has to be less than or equal to 2. So all these points down here have y coordinates that are less than or equal to 2. everything above that line would have a y-coordinate that was bigger than 2, so it wouldn't work for that inequality. Okay, now, for vertical lines, we just call it vertexal to help me remember. It's going to go through the x-axis, and so x is 5. Oh, we probably should have done a better graph here. This will be all the way over to the far right here, but it would be all the points along that line. So you've got 5, 0, 5, 1, 5, 2, 5, 3, all the way up and down. The x-coordinates are all 5. The y-coordinates change as you go, but that's how it would look. And then I've got an inequality for this last one here. So this one says x is greater than -4, so should I have a dashed line or a solid line? Dashed. Okay, so these are not included in our answer. Now, normally when we were talking about this, I would tell you, like, greater than goes above, less than goes below. The only type of equation that doesn't work for is what you got right here in this last example. If you have a vertical line, I can't shade above or below. It splits the graph in half, left or right, so you got to think about it for a second. Which side of that line, left or right, would you shade if you want your x-coordinate to be greater than -4, left or right? Right, okay? All these coordinates over here, these have x-coordinates that are bigger than 4, and I'm just shading kind of lightly here, but all these points have an x-coordinate bigger than 4. On the left side of that, the x-coordinate would be smaller than -4. Is anybody having a question? Okay. Now, I've got some just plain graphs, and then I've got some inequalities also in example 3 here that I want to see if you guys can write me the equation or the inequality for what they have pictured. So if there's no shading, it's just an equation. If they have shading, then it's going to be an inequality. So, can anybody just raise your hand and tell me what would the equation of that first graph be? Yeah. Yes, ma'am. So y equals -1, done. Okay, now the second one is an inequality. So this one's tricky. Think about where the shading is. And that was a solid line. So what would you tell me the inequality is for the second picture? Eli, what do you think? Yes, x is less than or equal to, because that's a solid line, and then 3. Okay, what do we think? Could you write me an equation? This is just an equation, not an inequality. I don't have any shading. What would the equation be for that third picture? Yeah. X equals -2. All right. And then I've got one more. Now, this guy's an inequality. So this is a dashed or dotted, however you want to say it, line. And it's barely visible, but the shading is, if you can kind of see it, is on top of that dotted line. And what would you write down as your inequality? Y is greater than 5. Okay. Is anybody having a question about the horizontal and vertical lines? Question. Now, we're going to kind of add into the mix here parallel and perpendicular lines. So I just have a couple graphs here. One's for perpendicular, one's for parallel. So just tell me, forgive, I should probably have some arrows on the ends of these graphs, and I totally didn't put those on there. If you think about perpendicular lines, and first of all, I don't really like to write out the word perpendicular because I'm lazy and it's really long. So if you ever see, looks like an upside down capital T, that's an abbreviation for the word perpendicular. I will probably exclusively use that instead of writing that word out. What do you think of when you think of perpendicular lines? Like what do you remember, maybe geometry or algebra 1, about perpendicular lines? Yeah.
The slope is reciprocal.
You're so close. Okay, the slopes are, he said reciprocals. There's one more thing you have to have with that. Yes, you just said one has to be positive and one has to be negative. So we call them opposite reciprocals. And let me see here if I can, are these decent slopes? Here, I'm going to grab 2 points here. Like there's a point here, there's a point here. This one has a slope of up to over 3. And there's a point here, point here. This one has a slope -3 over 2. So opposite reciprocals, they are flipped over. The 2 in the picture here that you have are going to be 2/3 and -3/2. Now, they have to be opposites to create the shape that they create. Does anybody remember specifically though, like what, this is true. What do I have to have if my lines are parallel? Like what else is true about them? Yes, okay, so those opposite reciprocals, these intersect at a 90-degree angle. So if you guys are on the graph here, where these guys run into each other, that creates 90-degree angles. There's 4 90-degree angles that are created there. I just marked a couple. But that's your requirement to be perpendicular. Okay, now parallel lines. Here's an example of parallel lines. What's true about parallel lines? Yeah. They have the same slope, for sure, but they have to have what? Same slope, but yes, different. I know that's picky, and you guys can see on the graph that these obviously don't have the same y-intercept, but if you have the same slope and the same y-intercept, it could be a situation where you have the same line. So it has to have a same slope, but a different y-intercept. And these lines, in terms of an angle or something that they create for perpendicular, it's 90. For parallel, these never intersect. And you guys can see that in the picture, hopefully. Those two lines will never run into each other. All right, so perpendicular slopes are opposite reciprocals. Parallel slopes are the same. Is anybody having a question? Okay, I'm gonna have us do just a little bit of algebra here on the back. Okay, so this first question, it just says write the equation of the line. So I'm gonna write that lovely point slope formula that we talked about yesterday. If you guys prefer to start and plug it into mx plus b, I'm fine with that. I would recommend trying to use point slope though, because I know they are going to use that formula in the pre-calc and trig. So anywho, this says write an equation of a line that is going to go through a specific point. So that point for this question is 3, -4. And I want to be parallel to 2/5 x minus 3. Okay, if I want to be parallel to that line, what does my slope have to be? 2/5, right? Okay, so really that's all you need that for. You're not going to plug anything into that equation. Your parallel slope is going to be 2/5. Okay, now this is not the nicest question in the world in terms of what this is going to turn out to be, but I want to go through this with you because a couple of the questions on Math Excel, they don't have the nicest answers. Once you have used that, don't use this line for anything else, just steal its slope, and then you're going to plug it into this point slope form. All right, so the point I'm supposed to go through, this would be your x1, y1, and so it'd be y minus a -4, so I'm just going to write y plus 4. And copy the slope, 2/5, and then it's x minus the x-coordinate of the point, which for that lovely example is 3. Okay, now I'm going to distribute this. This is not going to give me the nicest value in the world. So I'm going to do, for my slope, I'll just go ahead and leave like 2/5 x. Leave it in that format. Okay, now if I have to multiply 2/5 times -3. I don't usually write it out, but you don't have to have a common denominator. You just multiply straight across the top, straight across the bottom. What I do the numerator times the number. I just say this to myself in my head. So I do 2 times -3, which would be -6, and divide by the denominator, which is 5, which doesn't happen to reduce. Okay, now to get it in slope-intercept form, I got to move that 4. All right, now, if you want to do it by hand, that is completely fine. You will have to get a common denominator to do that. I want to show you real quick my favorite button on the graphing calculator. So if you guys have a scientific, you can just use the fraction key. But if you've got your graphing calculator, I'm just going to show you a little cheat that I literally use every day, probably. So if you've got one, and I know I will go over this instruction again. So just to show you real quick, there's not really a fraction key on all these graphing calculators. Some of them have one, but it's like a couple menus to get to it. So I'm just going to show you a cheat. I'm going to take -6/5, and if I have a fraction, I just put that fraction, like I do -6 divided by 5, I just put that in parentheses. And the parenthesis keys are right above the 8 and the 9. And I'm going to subtract 4 from that, right? Just minus 4. Okay, now, all you have to do from here, there's going to be a button that says Math. And let me scooch this up. It's over here on this side, right under the alpha key. If you hit the Math button, it takes you to this nasty, complicated menu, but that's cool. You actually want the very first thing. You're just going to hit the Math button and hit Enter 2 times. Just enter, enter, and it will convert that into a fraction in lowest terms for you. So it's just a little cheat. You probably could have done that by hand, but I'm just having you use your resources here. So then this would be negative 26/5. Not the greatest y-intercept in the world, but I'm not asking you to graph it. I'm just asking you to write the equation. Okay, is anybody having a question? Right, now the next question is the same problem, but they're going to present the equation you want to be parallel to. It's not in slope-intercept form, it's going to be in standard form. Okay, so I'm going to be parallel again here. And I want to go through this point 7, 2. What would you have to do to figure out the slope of the line parallel to the line that they have written in the problem here? Because it's not obvious in standard form what the slope is. What would you do to figure out the slope of this line? Anybody know what the slope of the line would be? Yeah, just do it just real quick. Okay, you're just going to add the 6x, right? And I'm going to come over here to the side a little bit. This would be 2y equals, now if I move that 6x, just my recommendation, write that right after the equal sign. That 8's positive, just slide that over a little bit. And honestly, it doesn't matter what the y-intercept is. You really just need to figure out what the slope is. It ends up being 3. I'm going to fully go ahead and write that out in slope-intercept form. But really all I need from that is what is the slope going to be. So to get the slope, if you want to think about that, here, I'll tell you what, let me write this. Let's say you have this. If you solve this for y, what you're going to do is you subtract ax from both sides, just like a little tiny review of our literal equations here. So I'd have by equals negative ax plus c. I would divide everybody by b here. So if you do end up with the standard form instead of the slope-intercept form, your slope should always end up being in that standard form negative a over b. That's what I had, right? Opposite of b would have been 6 over a, which is 2. 6 over 2 gave me the 3. So if you want to use that, if you want to remember that, you can do that as well. The slope would always be negative a over b. Okay, now once you have that, you're golden. You just need that slope. So I'm going to use that slope of 3. So my parallel slope is 3. And I'm just going to plug it into that point slope formula again real quick. So I would do, this one will have a nice, no fractions on this. Y minus the y coordinate equals your slope, which we just spent a lot of time figuring out was 3. And then x minus the x coordinate, which would be 7. So always just 2 steps once you're in that point slope form to get it in slope intercept. This is going to be 3x minus 21, and then I'm going to add the 2. So we're going to get 3x minus 19. So it's a little bit nicer looking than the question we just did. Is anybody having a question? Okay, now, those were both parallel. So parallel, you just copy the slope, plug in the point they give you. If you got to do perpendicular, all right, so I'm going to give you a point here that says negative 5, 6. And I want to be perpendicular to this line, y equals 3 over 2x minus 5. What would a slope of a line be perpendicular if I have 3 over 2 as my slope? Negative 2/3. One has to be positive and one has to be negative. So the one they gave me was positive, so the opposite has to be negative, and then you just flip that slope over. Okay, let's see here. Now this one is going to be kind of like the one we did at the top where it doesn't have a nice answer. So if you want to practice that little thing I showed you on the calculator, I'll do that again here. So it's y minus the y coordinate of the point, which is 6. My slope perpendicular has to be negative 2/3. and then x minus the x-coordinate of the point. The x-coordinate ends up being -5 here, so minus a negative would actually be a plus. Okay, now if you're going to multiply that -2/3 by x, just go ahead and write it right next to it. Now, when I do this, what I'm going to do is -2/3 times 5. You can do it by hand, or if you want to try and practice that with the calculator. Again, I just put like -2 divided by 3 in parentheses. You can put the negative with the numerator or the denominator. Don't put it with both because that would make it positive. And then I'm going to multiply that by 5. And I can just do that math, enter, and it'll tell me right there, -10/3. And then all I have to do is add 6 to this to get it in slope-intercept form. So I've already got that on my calculator screen. So I'm just going to add 6 to that. And since I already had the fraction there, it'll leave it in fraction form. So it's going to be +8/3. If you did that by hand and you did -10/3 and then you add 6 to that, you got the decimal, you can just do that math, enter, and it'll convert it for you. And we don't want to use mixed numbers. We want to use an improper fraction, like that's 8/3, so you can see it's 2.6 repeating as a decimal. I don't want to see 2 2/3. I'd rather see the 8/3 for you. Okay. Now, I have one more, and then we're going to practice at the bottom a little bit. Okay, now, if you've got an equation you want to be perpendicular to, and you can't see the slope here because this is standard form, you can totally transform it if you want. We're going to subtract the 4x real quick. Or you could do that -a/b that I wrote up above. It's completely up to you. Doesn't matter what the y-intercept is, just matters what the slope is. Just remember, if you're going through here and doing this work, you don't want to copy the slope if it asks you to be perpendicular. So I ended up with 2 as the slope. So if I want to be perpendicular to a line with a slope of 2, what would the slope be for a perpendicular line? -1/2. Okay, got to be negative because that one was positive. So flip it over and then make it the opposite. Once you're there, we're just going to plug in this point. This one will be nice. So I'm going to do y minus the -3. So it's going to be y plus 3. -1/2 is our perpendicular slope. X minus the x-coordinate of the point, which ends up being 8. So I get y plus 3, -1/2 x. Now, -1/2 times -8, the negative times the negative is turning into a positive. So you're going to get 4. And then you just got to do one more little thing. We're going to move the 3 here. So I'm going to get -1/2 x plus 1 would be perpendicular to that line, but through the point 8, -3. Is anybody having a question? Okay, now I'm going to kind of throw back to what we were doing at the beginning with the horizontal and vertical lines here at the bottom. Okay, I'm going to have you write the equation, and you don't have to use a graph. I put a graph on here so we could think about it. Okay, so it says write the equation of line parallel to y equals 3. So I'm just going to sketch y equals 3, a nice horizontal line at 3. So I want to be parallel to that line, and I want to go through the point -2, -1. Okay, so I just plotted that point just so you can kind of get a visual. What would I have to write down as my equation if I want to be parallel to y equals 3, but I want to go through this point -2, -1? I would not go through the process we just did. I would just, this is just going to be, if it's a horizontal or vertical line, don't go through that process we just did. It's just going to mess you up. Just think about this. What would the equation line have to be if I have to go through that point and be parallel to the line I put on that graph? What would it look like? Like, could you draw it? If you're going through this point, would you go left, right, up, or down? If I gotta be parallel. Okay, I can't tell if you guys are just like not sure or, okay, right, it would have to look like this, yes? Okay, if I have to be parallel to a horizontal line, it just has to be y equals a number, so it's just gonna match the y coordinate of that point. For this example, that has to be -1. Okay, don't go through the process unless you have an actual point and you've got an equation that has a slope. If your slope is 0 or your slope is undefined, don't go through that process we just did with those last examples. You want to make sure you go ahead and just think about this logically. Horizontal and vertical lines, it's not bad to do. Okay, now I'm going to ask you similar question, but perpendicular. So it says I want to be perpendicular to y equals -2. So just give you a little visual. Here's y equals -2, nice horizontal line. All right, and I want to go through the point, I want to be perpendicular here. I'm going to go through the point 4, -3. So if I want to be perpendicular to that line, what would it look like? Yeah. Yes. Okay, we got to go up and down here, right? To create perpendicular, a horizontal line and a vertical line are perpendicular to each other. So it's just going to be x equals the x coordinate of the point. If you got a horizontal line, y equals the vertical, I'm sorry, the perpendicular has to be x equals. If you have parallel, they both have to be y equals just a number, or just if you have vertical lines, they both have to be x equals a number. Is anybody having a question? Okay, now, you guys should have scrap paper.